Hey guys, so this video is to talk about one type of special right triangle, okay? And so special right triangles, there's going to be two kinds we talk about, and they're just triangles where if we know they have these certain angles, then they always have these certain side ratios, okay? And so the first one's the 45, 45, 90, and that means that if you know you have a triangle that has 45 degrees for one angle, right? 45 degrees for another angle here. And then the last angle is obviously going to be 90, right? Then if their side lengths, the sides across from the 45-degree angles, this is an isosceles triangle. So those side lengths are always the same. So for right now, we're just going to pretend they're x, okay? If those side lengths are x, and they're always going to be the same if it's a 45, 45, 90, then this side length is always x times the square root of 2. Okay, and we can find that using the Pythagorean theorem, okay? And so I'm just going to do that really quick, and then I'll show you, we'll look at an example of where we might use this to solve like a problem, okay? So if we knew that this was x, we know that because it's a 45, 45, 90, these two angles are the same, that these two side lengths are going to be the same. So we know that's x. The Pythagorean theorem says what? A squared, call this a, plus b squared, right, equals c squared. So let's just pretend that we didn't know this side length, but yet it's c. Okay. Well, x squared plus x squared, those have the same variable raised to the same power, so we can combine those. 2x squared equals c squared. We want to solve for c, so let's just take the square root of both sides, right? And if we were to simplify the square root, right, the square root of x squared is just x comes to the outside, and it leaves 2 on the inside. And then we're left with c over here. So c is equal to x times the square root of 2. And this is always going to be true. So what that means is that if we have a 45, 45, 90, and just pretend with me that this is 45, 45, 90, okay? And we know that one side length is, say, 1, right? Then we know that this side length is also 1, and we know that this side length is 1 times the square root of 2, okay? Or if we have a triangle, again, you're just pretending with me that this is a 45, 45, 90, and this side length is, maybe we know this side length is 3. What does that tell us? We know that this side length is what? Equal to x times the square root of 2. So what is x? We need to know our other side length. And so we just divide by the square root of 2. Whoops, square root of 2. And I'm going to come down here. I'm sorry, this is sloppy. 3 divided by the square root of 2 is equal to x, but we don't want a radical on bottom. So we can just multiply by the square root of 2 on top and bottom. And we get 3 square roots of 2 over 2 is equal to x. And so now we know that this is equal to, right, 3 square roots of 2 over 2. And this is equal to 3 square roots of 2 over 2. And if you wanted to check that, because it's kind of harder to go that direction, but if you wanted to check that, we could just say, well, is this multiplied x times the square root of 2, is that really 3? And so if you say 3 square roots of 2 times 2, or divided by 2 times the square root of 2, right? If you multiply square root of 2 times the square root of 2, you get the square root of 4, so 3 square root of 4 over 2. That square root of 4 is just 2, so 3 times 2 over 2. 2's cancel, and we're left with just 3. So that does work. So you can go either way. They can give us, but basically if we know we have a 45, 45, 90 triangle, right, they can give us one side length, and we can solve for any other side length because we know the relationship between all three sides if it's a 45, 45, 90, okay?